Hi, welcome to modeling problems for linear inequalities. So these are a few, about I think 6 samples of possible problems that you could get for linear inequalities. Okay, so let's start with the first one. Emma got a new job and will have to move. Her monthly income will be $5,265. To qualify for or to rent an apartment, Emma's monthly income must be at least 3 times. So could it be more than 3 times the rent? It could be more than 3 times, but it has to be minimum 3 times. Okay, so monthly income has to be greater than 3 times the rent. And now it could be the same as 3 times the rent, but it has to be minimum, it has to be larger. Okay. What is the highest rent Emma will qualify for? So now I know what my monthly income is. Okay, I know I'm just going to represent the rent as an X. And so I'm going to do 5,265 has to be equal to 3x. And so now we would solve, just like we would solve a normal linear inequality. I'm going to divide by 3 on both sides. And you should get that 1,755 is the maximum rent, okay, that she can pay. So 1,755 is the highest rent she can pay, which means she can pay less than 1,755, but she cannot pay more than 1,755. Okay. So the next one, Dawn won a mini grant of $4,000 to buy a tablet computer for her class. The tablets she would like to buy cost, so this is the total amount she can spend. Okay, and the cost of each tablet is $254 with 12 cents. What is the maximum number of tablets Dawn can buy? So if I know that I can spend at most $4,000, then but I could spend less. We have the same situation as the problem above, where we have the total amount to spend is going to be the largest possible number. So $4,000 is the largest amount, and everything else has to be smaller than that. Okay, so I'm going to do 254 with 12 cents, which is the cost of each tablet, times the number of tablets. And I'm going to say X is going to equal the number of tablets bought. Okay, so times X. And again, same thing. I'm going to divide both sides by 254 with 12 cents. Okay, and when we make that division, that means to say that we have 15.74, and that is the most amount of tablets she can buy. Now let's think about this. Logically speaking, can I have 0.74 of a tablet? No, I cannot. But my grant amount will not cover a 16th tablet. So the maximum number of tablets Dawn can buy is 15. Okay, because I know that with 15, the grant money will cover that much, but it will not cover a 16th fully. All right, so our example number 3. Pete works at a computer store. His weekly pay will either be a fixed amount. So this is option 1. Option 1 is they will pay him a fixed amount of $925. Or, so here we have option 2. Option 2 is they're going to pay him $500 plus 12% of his total sales. Okay. So here are my 2 options. So we want to make sure that we have option 1. And that's fairly easy. That's $925. And then option 2, where we have $500 plus 12%, which we can represent as a decimal as 0.12 times his total sales. Okay, which I'm going to call X. All right. Now, how much should his total sales be for his variable pay option, which is option 2, to exceed the fixed amount? So I want option 2 to be greater than option 1. And then I want to figure out what my total number of sales has to be. So this is going to be now my inequality. So I'm going to have 925 has to be less than 500 plus 0.12x. So again, I'm going to solve this just like what I would solve a normal linear equation. Now that I understand what's going on, I'm going to subtract the 500, okay, which gives me 425. And then I'm going to divide both sides by 0.12. Okay, and I'm just going to move this here. I'm going to kind of like make an imaginary line so that I don't get all confused. And then I'm doing 425 divided by 0.12, which gives me 3,541.67. So 3,541.67, this is the amount, the minimum amount of sales that Pete needs to make in order for option 2 to be a better option for him. Okay, so we're going to say Pete must sell at least 3,541 with 67 cents for variable pay to exceed the fixed amount. Excuse my sloppy writing. Okay, so now we're comparing pay options. The next one, so this is example 4. Example 4 says Sergio and Lizeth have a very tight vacation budget. They plan to rent a car from a company that charges $75 a week plus $25 or 25 cents a mile. So just to rent the car, fixed price, they are paying $75 plus they're paying 25 cents to the times the number of miles they travel. Okay, and you can call this M if you want. I'll call it M as well. How many miles can they travel and still keep within their budget? So they have they want to spend $200 or less. Okay, so now I have another equation, or sorry, not equation, inequality. Equation would just be equals, which I do not have. And again, just like the problem above, we're going to subtract that 75 from both sides. So I have 125. Okay. Now I'm going to divide by both sides by 0.25, which means that I can, or they can, drive 500 miles and still be within budget. Okay, they can drive at most 500. So they can drive no more than 500 miles. Okay, so again, understanding the problem and what is that it's asking for is actually super, super important, okay? And it really helps set up the problem correctly. So example 5, Elliot has a landscape maintenance business. His monthly expenses are $1,100. If he charges $60 per job, how many jobs must he do in order to earn a profit of $4,000? So we have a lot going on here. So he has a monthly expense of $1,100. Okay, so he already is in the hole $1,100. So he's starting out, that's what we call a deficit. He's starting out at a deficit of $1,100. Now, he is making $60 per job. Okay, so that's going to be $60 times the number of jobs, which I'm going to call J. Okay, now he wants to earn at least $4,000 a month. So could he earn more than $4,000? He could earn more than $4,000. So when we are setting this up, we want $4,000 to be the smallest number. Okay, meaning to say he can make more than $4,000. So I'm just going to write this with my variable again, and let's go ahead and solve it. So I'm going to add 1,100 to both sides. So I have 5,100. And then I'm going to divide by 60 on both sides. So that means that he has to do minimum 85 jobs in order to be able to make at least $4,000. Okay, so he must do at least, or you could even say a minimum of 85 jobs. Okay. All right, last problem here. So this one kind of is going to be a little bit more of a multi-step. All right. So Brenda's best friend is having a destination wedding. The event will last 3 days. Okay. So she's going to have 3 days of expenses. Now she has $500 in savings and can earn $15 an hour in babysitting. So her income, or the amount of money that she has, is going to be $500 plus 15 times, which is the amount she charges per hour of babysitting. So I'm going to say times hours. Okay. Now she expects to pay $350 for airfare. So we need to account for $350. That's going to be an expense, plus $375 for food.